All right. Good morning. Welcome to the seventh lecture of COMP1511. Welcome to week 4. And yeah, there's a lot happening. All right, so let's go through all the news. Well, let's first talk about something that's outside the course. You've probably noticed there's been a COVID outbreak in New South Wales and pretty close to UNSW, with Bondi Junction Westfield being a major area. In fact, they're urging, I think everyone is in Bondi Junction Westfield, which is a hell of a lot of people, and probably including some of the people in COMP1511 in the last week to get tested. All right, so please follow the public health pronouncements. Yeah, I know you're all young and healthy and are very unlikely to suffer much in the way of ill effects, but you're also very worried about passing it to someone much older, like grandparents and so on. So follow the announcements, get tests, that sort of thing. But the huge thing is, if you've got anything resembling a COVID-19 symptom, do not come to campus. So we're all well set up here. You can tell your tutor, if you've got a face-to-face tutor, we'll make arrangements. But it's incredibly important that if you've got anything resembling a symptom, don't come to campus. Talk to a doctor, get a test, one of these things, but don't come to campus. All right. Hopefully we'll soon all be vaccinated. We'll all be on campus. It'll be, and you can come up to me and introduce yourself when you do this. I was in your class in T2, Andrew. But all right. What else is happening? Well, the coding is getting serious. Week 4 lab exercises, we're tackling arrays for the first time. Arrays are amazing things. They let us do the huge part of computing. We're really seeing the real heart of computing, the power to do almost anything as we see arrays, as we take our first steps with arrays. So we're taking our first steps with arrays in week 4, which is pretty tough because last week we only took our first steps with loops. So last week's lab was where we got serious with loops. So the course is getting very intense right now. Now, I should say a lot of the class is feeling stressed and wondering whether they'll cope. And first period programming courses are really stressful. I think we do it better than most. We give out support better than most, and we try to get the fraction of students that get through our course, even though it's a pretty hard course, is better than most programming courses around the world. But still, and yeah, so most of you will get through the last, and many students have done the course before, so you can do this. But yeah, it is hard. It's hard for all of us. I should say, in past years, I can remember having students talk to me, in the middle of term, saying, "Andrew, I'm not sure I'm coping," and I've talked to them about what they're doing, and they're saying, "No, I'm getting the standard lab exercises done, but I couldn't do the challenge last week," and things like this. And I've then subsequently hired them as tutors in a year or two later. So a lot of students underestimate. So please, the worst thing that can happen is you can get so stressed and worried about doing the course you stop trying to do the course. You've got to stay in there. Even if there's a lab exercise you can't do, there's something in a tut you can't do. Focus on what you can do and keep trying to do what you can do. Keep trying to do parts. Some students just can't cope with the fact they can't do every lab exercise or understand every tut question, and disengage, stop working on the course, stop doing the easier stuff, and then they're in trouble. Stay with us, stay working, stay talking to your tutor, treat each week as 1 week at a time.
I do want to emphasize the talk to your tutor part as well. Like, it is like, your tutors are there for a reason. They are incredibly helpful. Well, I'd like to believe that we are incredibly helpful. And if you are ever sort of looking for assistance, or you want some advice, or you're not sure whether you're on track, they are the first port of call, and they are going to they'll be happy to talk to you. They'll be happy to give you advice, and almost certainly they'll be happy to reassure you, because I think Andrew's right. Like, this course is a difficult one. I think it's absolutely doable, and we have loads of people who go on to great success in future courses. We get hired as tutors and that sort of stuff. But it's okay that this course has a reasonable amount of work, and you can get support for that if you want it.
When Tom says reasonable amount of work, I'd say huge. You will do a huge amount of work in this course. If you're in a computing degree and you want to be in a computing degree, you'll love this. and you won't mind doing a huge amount of work. If you're another degree, you may discover you love computing, or you may discover you chose wisely when you went into mechanical engineering, and you just need to get through the course. I would say another thing. The CSE, the Computer Science School, got a new head of school last year, and he came out to Australia, for an interview and to see whether he wanted the job, and John Shepherd and I, who run the teaching, were talking to him and trying to tell him, it was a good place to come. And the first thing we went to in trying to say, UNSW had a great computer science school, was we started talking about the tutors, how we had this amazing community of undergraduate tutors, and he was impressed, and he now agrees, having met many of our tutors. So talk to your tutors; they're fantastic. All right, and if you're loving the course and doing pretty well, think about becoming a tutor. All right. There was one more thing, wasn't there? The assignment is on two more things. My goodness, it is a busy time. First thing, the weekly tests. Our first weekly test came out last Thursday. It's due at 8 o'clock this Thursday. So don't forget that. And our next weekly test will come out this Thursday and be due in a week's time. Similar pattern. Again, for the weekly test, set it up as a mini exam. Shut the bedroom or wherever your door or wherever you work. Set it up as a tiny mini exam and see how you go in an hour. At the end of the hour, note where you're up to. Note how you've done, and sort of put a little. If you have a diary, note in your diary. I did 2.5 questions. I'm doing well in 1511. So that's a bit of feedback to you and a bit of practice at exam-like conditions. You can then go on any time up till 8 p.m. on Thursday to do the remainder of the test, anything you couldn't get done in the hour, but really treat it like an exam. Build up, we've got to practice to do things well, so much practice. So it's a little bit of practice at a computing style exam. Demonstrating coding under pressure. The other thing that's happening is assignment 1 is out. So it just came out, I think, late last night. It's a really nice assignment. It's a classic sort of first coding assignment in a nice friendly domain. The spec is out. Tom's going to run a live coding session at 5 o'clock today. I think he's already sent you an email announcing this. The link will be on the lectures page. So live coding session today to do with the assignment. You want to know more about the assignment. The assignment due date, I think, was July 9. It's about 3 weeks away, so it's a very busy time. So you're thinking of taking a 1 week ski holiday. Really rethink it. It's not really compatible with studying COMP1511. Plus side is it's cold, it's rainy. Sitting inside and coding is probably a good thing to be doing. Okay.
There's a question there which I might just quickly jump in and answer, which is yes, we'll record the sort of live stream this afternoon. One of the things that we're going to try and do is make it so it's sort of bite-sized, so that you can, if you've got a question about a particular thing, you can jump to a time code and you'll be able to see it. So hopefully there'll be a resource that gets added to the assignment spec after this afternoon. But yes, it will absolutely be recorded.
There's a good question in the test and in the chat about Autotest and the tests. There's someone saying, is it worth submitting if I don't pass if I fail Autotest? No, definitely submit whatever you've done in the tests. This applies just always. There may be marks available for an exam question, a text exercise, a lab exercise for submitting something. Even if it's got a bug and the Autotests are telling you, no, you've got a bug here. Equally, just passing all the Autotests doesn't mean your program is perfect. So it could have bugs that the Autotests don't check. Most programs have bugs somewhere. In marking things, we generally use different marking tests. We're a little bit worried about some people get in this habit. They focus on the Autotest. They forget about what the problem they're trying to solve is. Print the first 10 prime numbers or whatever, I don't know. They forget about the general problem and just focus on passing Autotest 5, Autotest 6 and Autotest 7 and write special purpose code, essentially if statements that only work for the Autotests and break on everything else. And we don't want that. So we try things that are slightly different. We don't try to fool you. We generally don't try to fool you or hide things. No, we never try to do that. With the Autotest, we want you to know straight away how good your program is. But how good your program is, we check by using different tests generally.
I might just also very briefly jump in and say the one exception to what Andrew was just saying is that there are some lab exercises, including I believe one this week, or it might be next week, that does specifically say like we don't give you all of the auto tests, and that's because it's like a challenge where we're trying to get you to think about those things. So just watch out for if it has one of those flags. If it is in fact this week. But there's a big red banner that says this challenge does not provide comprehensive test cases, so hopefully you won't miss it.
Yeah, I should say constructing test cases is a real part of coding, and we only take baby steps with that in this course, but we do take some steps with it. Yeah, later on, the notion that you'd have a complete test suite provided to you, it's that sort of luxury. You'd have to write the test suite. So we in one or two places we'll get you to do a little bit of writing the testing. Expect to do much more in a course like COMP1511, for example.
Yep. The other thing I just want to add quickly, Andrew, which you've reminded me of. We've enabled the style checker on the Autotest system so that when you Autotest now, you'll get a message at the top of your Autotest which either says your style looks good, just make sure you check the manual issues, which is basically like we couldn't find any problems, but you still possibly could have named your variable something crazy. I saw once a variable named uwu, which I thought was not a particularly good variable name. And then if not, it'll just come up with a big warning at the top saying, please run one fo on one style. And you'll get reminded that you need to do that just when you're auto testing.
I would say the classic one is, someone who has a crush on, Veronica in their maths tute, names all their variables after Veronica. We all want you to find love, but really it doesn't make your program readable if you name your variables in that way. So the style checker does the easy stuff. You haven't indented that if statement. Gives you feedback you haven't indented that if statement properly, you haven't put spaces there. It checks some easy things, so then that means you can get those immediate feedback about those. For smarter feedback about choice of variable names and structuring functions, you'll have to go to your tutor. All right, let's now do some recapping in last week's episode. What happened in last week's episode? All right, a lot happened last week, so we're going to spend a little bit of time recapping. So we saw functions for the first time. Yeah, we're going to be looking at functions and new aspects of functions and coding with functions for weeks to come, right into the end of the course, basically. But we have to introduce them now because, for example, for the assignment, you need to use functions with the assignment. Only for the second assignment will we expect you to be good at writing functions, though. So what do we do with a function? What do we know about a function? It has a name, and we introduce it beforehand. Actually, that's not such a great one. I had a better function here, I think. Yeah, this one's better. So this is a function we looked at. It's a function that does something useful. It calculates x to the power of 3. Now, it's a key thing. Braces, they're a tiny character, and they have a couple of uses. One is they set out a set of statements to be a group, and they could be the group that's part of our if statement. So we've seen them used to delimit, mark the edges, mark the borders of an if statement, and a while loop. So that's one thing they do, is they set up a block of statements and say these are the ones controlled by the if, these are the ones controlled by the while. There's a second thing braces do, is within them they set up a world for variables. So if you put a variable within the braces, it exists only in that world. Functions also have braces, so that means these variables here exist only in that world, and these variables here in a separate function exist only in that world. So you can actually have a variable A and a variable B inside this function, and they're different variables. Practiced programmers will do that all the time. They're so used to functions being different worlds, they'll use the same names in all their functions and won't worry about it at all. I'd actually encourage you to mostly use different names, or just use different names for variables everywhere for now, until you're really comfortable. It's easier for you to think about it as a beginner programmer if you don't reuse the name inside a function. So you have function main and function cube. If you use different names for your variable inside functions cube, that will help you keep your head straight for now. You don't have to do that, but I think it'll help you. Now, there's actually two variables in the function cube. Yeah, this is a weird one. So x is actually a variable. Well, I guess that's not a surprise. We've given it a type and said double x. X is a real variable. It exists for these braces. It's a very special variable in that it gets initialized without you saying anything. You know, other variables only get initialized when you say variable equals something. So they only get a first value when you say so. X gets a value instead whenever his cube is called. X is the first parameter to cube, so it gets the value of whatever is the first value passed to cube. If we look up here, the first parameter is the value of A. We look back further, it's 2. So in this function call here, x will be initialized to 2. Now some of you like trying things, and it is actually an experiment, pushing the boundaries. It's a great way to learn about the language. You might be saying, well, can I assign to x in this function? The answer is you can, but you probably shouldn't. It probably makes your function a bit hard to read if you give x different values other than the one that was initially given. But it's a real variable and you can change it. Okay, and here's the other big recap: return. What does return says? Two things. One is go back to where you came from. So that says execution of this function is done. Return execution back to where you were called from. In this case, execute line 13. But it does something else as well. It says this function gives back, outputs if you like, gives back a double result, a double value. It says the double value to return is whatever's in the variable result, and that is the value of this. And in this case, we're putting it in B, and that's printing out. Now I need to do something to make this a better example. Let's have another double variable, and we'll calculate the cube of cube of 3, and we'll print out what 3 cubed is. Why am I doing this? To show you a function can be called in multiple places, so it goes back to where it was called from. That should be good. Oh, didn't say where to put the code. Let me say where to put the machine code, and I'll run it, and we should see it print out 3 cubed. Look at that. So we see the joy of functions. You can use the same code over and over again. It's not so exciting when we're writing 10-line programs, but I've talked about how the operating system I'm using here is also written in C. So Linux is written in C, and it's about 1 million lines, I think. 50,000 functions. So that the functions let us write software in that scale, or work on software of that scale. And it's quite possible in a year or two, some of you will be, getting the Linux source and changing it, modifying it, working on a device driver, tweaking a file system. Seems a little way away, but you can get there. All right, so this function is called here, executes down here, and then the return takes it back to there. It's called again and goes back again to where it's called from. So functions always return from where they're called from. And they could be called from many places in a program. And that's the joy of functions. So that's cube. I had a more complicated function. Well, it's not that much more complicated. This is just showing a different shape of function. I'd call it prototype. Now the C compiler doesn't do multiple passes, multiple looks through your source code. It just goes through it once. So whenever it sees a name like this, a call to a function, it wants to know what it is. It's always got to be told what something is before it's used. So we tell it x is a variable of type double, and then later on we can use x. Main is a really special one. That's part of the C language, that there's a main function. But printf is a function, and it's told, the C compiler is told about it there inside that file, which we don't need to go and look in there. But it's warned beforehand what printf is. So if we're going to have a function called evaluate quadratic, we have to tell the compiler a couple of things about it. How many inputs, how many parameters or arguments, that there are 4 words you might use. People who do a lot of coding will either say argument, probably say argument, might say parameter. So we're told it has 4 arguments, and they're all of type double, and its return type is a double. Now this doesn't actually tell the compiler what the function does. What the function does, the actual definition of the function, is further down there. But that's enough for now. So it's enough so the compiler can work out what to do if that function's called. If these were, for example, integer arguments, the compiler would have to do something different. Alright, so that's a function to evaluate a quadratic. Those of you who are worried about, are we going to be introducing maths in the course? No. These examples get used because we think you remember Year 9 maths. If you don't actually remember Year 9 maths, it's okay. There won't be an exam question you fail because you don't remember what the formula is for the roots of a quadratic. But we think you had spent so much time with this in the last few years, it's a comfortable place to show you coding. And there was an
you just as a note, you might want to change line 9 so it's got a void there rather than the argc stuff, because there's some questions about it. Probably best to for context. That's something we'll learn about later in the course, but for the moment you can just pretend that that's a void.
I didn't notice that. So these are the same programs. Yeah, interesting. Well, that's a bit of foreshadowing for you. The mark of quality drama, not so much quality lecturing though. When you're watching that show on Netflix and there's a weird little thing happens, you're thinking, why did they put that there? It's usually because that's introducing the murderer who's going to appear in the next episode or whatever. But anyway, well, I guess that will appear. What goes there will appear in an upcoming episode, but you don't need to worry about it for now. Void gets used for a few things. Don't freak out about it. Quite a few things. Alright, so that's functions recapped. What else? It was a big week last week. Arrays. Right. So if you're on top of arrays, you can relax, stretch a bit, and we're going to recap arrays because they're so important. They're such a big concept, and you need to get across them right now. You have this week's lab exercises and the assignment. By the way, don't panic if you're not ready to start the assignment this week, but if you're not ready to start the assignment by, say, Monday next week, I'd be getting more on trying to get more on top of things. You've still got a little bit of time, maybe. But I would strongly urge you to try starting if you can. Just don't panic if there are things you don't understand yet. Once you've sort of fully absorbed this week's lab exercises, I'm hoping you'll be ready to go on the assignment. All right. So, I fixed this slide. I haven't. There's some typos in it, but that's okay. The Notionals context is I've got 900 COMP1511 marks which I want to process at the end of the year. How do I do that? I could write a program where I have a separate variable for every student's marks. 900 variables, but it's you can make a program do this. It's just incredibly tedious, because then if I want to do something different for every student who's scored greater than or equal to 50, I have to write 900 if statements. Then if I want to do different for every student who's scored greater than 85, I've got to do 900 if statements. It's just impossible. If you declare everything as separate variables, all you're left with is ifs, and you can't do things easily this way. How do you get out of this impasse? You get out of this impasse by using arrays. Now, a single variable can hold one value. We've seen two types, int and double. One holds a subrange of the integers, one holds approximations to real numbers. But it's one value, just one. An array gives the possibility, it's a variable that holds many values. So we can have an array that holds 5 values. It still just has one name, so we need to have a way of saying which of the 5 values we're talking about, and that's an index. And the indexes for a 5-element array in C are 0, 1, 2, 3, 4. It's an arbitrary choice. It could have been 1, 2, 3, 5. Could have been 2, 3, 4, 5, 6, I guess. But it turns out a lot of things sort of make sense if you start counting at 0. And you'll notice if you talk to your tutor that they'll be quite comfortable at starting counting at 0 for many things, because it works naturally for a lot of coding. But remember, to get the first array element, it's 0. To get if your array element has 50 things, that index will be 49. If your array element has 10 things, that'll be index 9. If your array has n things, this is n minus 1 is the index of the last one. So it's a whole collection of values, and we access them by indexes. I guess you could think of it as a block of flats, and you access it by the flat number. There you go. That's quite a good analogy. So this is a single house, block of flats, and each flat has a number. There's the syntax, the way of writing it, the exact characters you use in C. The name, same rules as any other variable. The type of the elements. So we've only seen two types, int or double. This one's int. Then square brackets and the size. And this isn't very good code. The size would normally be something you hash define. You see a number there, it almost certainly should be hash defined. But that's saying hold 10. So for this class, if it has 900 students, I could put 900 there and have 900 ints. Saying, can you have that many? Can you have 1,000? You will get into problems if you go to sort of 1 million for not particularly good reasons. If you try to make arrays of more than hundreds of thousands, it won't work well with our particular C compilers. There are other ways to do it, which we'll show you later in the course. But for now, you could certainly have. There's no trouble having 100,000 ints. And it's pretty common to write C programs where you might have 100 million elements in an array. Now, that's the initializer. Oh, that's the last part. Yeah, that's a bit weird. So you can specify a list of values there with braces around them. Saying, aren't braces already used for blocks of statements? Yes, they are. So this is giving braces a second meaning. I'd call it overloading the syntax. So yeah, your brain's got to cope with that. Oh, braces here are used for initializers. for now, you can just you've got to code this up. So you can just look at the lecture slide or look at the last example you did. If you don't specify enough values, all the remaining values are filled in with 0. It's pretty common to want to initialize the whole array to zeros, in which case you can just say the first element is 0 and then leave off all the rest, and it'll fill all the rest with zeros. It's a little weird, but you can remember that. Initialize all the arrays to 0. And there's a lovely graphical view of an array with student marks all through it. It's notionally 10. So this is the index you use to get at that array element. And you can assign values or use values from those array elements. Oh, lovely. I wanted to highlight something. So this says student marks is an array of int. That means anywhere you could use an int variable, you can put student marks, square brackets, and specify an index. And that gives you an int variable. So it's a two-part operation. Name of array plus index gives you int variable. And the amazing thing is, well, the index could be something I calculate. It could be something I calculate using other variables, and that lets us do really clever things. If we always just had indexes that were constant numbers like this, arrays would be boring. Arrays are amazing because we can do calculations and use those as index, and that lets us do powerful things. Yeah, sadly you can't scanf a whole array, you can't printf a whole array. You can do it for individual elements, so you do it with while loops. Alright, what did I want to that was too much recapping. Oh no, there's not one more thing to recap. Alright. There's actually a slightly better version of this program on link to the class web page, which reads these numbers in with scanf. But this was our first program with arrays, where we walk through putting in current player scores in a game. And look, and this is what I told you. Almost always, you're starting off an array, you want to hash define the array size. And almost certainly that value you'll be using on a loop. So we want to print out all the elements of the arrays, printing out the player scores. We do a calculation of the array index, and we can print out the player scores in order. And we can loop through, printing out player 0, player 1, player 2, player 3, saying, well, that's not great. I could have done that with 4 printfs, and you've taken 5 lines. So I could have done that with 4 printfs and 5 lines. That is true for num players is 4. But I can change num players to 4,000, and this loop just still works. I can make it 400,000, and that loop still works. You type in your 400,000 printfs and see how long it takes you. So we've got this enormous power now by computing this index, and it lets us in a few lines of code perform an operation for every element of the array. So what does this loop really do? This loop executes once for each index into this array. So this array has indexes 0, 1, 2, 3. So this loop executes once for each index, and we do something. And the something is we print out the player score. And that's so much coding we do with arrays. Let's go down one. This loop, what does this loop do? It's a little bit trickier. Oh, it is tricky. It executes once for each array element except the first one. So it starts at the second array element and executes once for each array index from the second array index on and says if this array element contains a bigger number than the previous highest player so far, then make this the highest player so far. Yeah, oh, that's clever code. Yeah, so I hope you went back and read through this and made sure you understood this. How would I work out more about this? One thing I've suggested is if you don't understand what's happening in a loop like this, add some printfs. Print out what J is, print out what highest player. So you could, to understand this code, you might get this code, link to the class web page, or also I send a link with my email, with my announcement email about where these things appear as coded. Get the code, add some printfs, understand it yourself. You think you can write it better? Try changing it yourself. What happens if you make j equals 0? And so on. Alright. And that calculated the highest player so far. So that's quite nice. Alright. And again, if I change this to be 400,000, this code here still works. Doesn't matter what num players is, this code works. So this whole program, you can just change num players to 5, 10, 50, 100, and the whole program just works. Change one little number there, and the whole program just changes. It's beautiful. I would say there's a weakness here. This probably should be a function. This definitely should be a function, and this probably should be a separate function as well. But functions and arrays, they're a bit tricky, so we haven't done that. We will show you how to do that, but slowly. All right. So that was nice. We've got another game coming up later in this lecture, a different game. So, and the assignment's a game. It's all games. They're actually a nice venue for practicing our coding. Right. Let me show you then. Let's recap that lesson in a different way. All right. So here's some code to. Oh, I've got to change directory. So that's this week's example. Let me show you. Just don't panic about this, but pwd is a command to show you what directory you're in. You'll notice that I'm actually in the class account. I'm not in my own home directory. You'll see home z1234567 / something if you do pwd normally. I want to go over to a directory that's up 1 and then down to 1. I can do it like that. And now my directory is this. Don't worry too much about that. But that's a nice little trick for you. Use of double dot. We'll cover double dot in great detail in COMP1511. Alright, so there is my example. I want to. What does this program say? Oh, it prints out reads 5 numbers, then prints them out in reverse order. So let's get that happening. See if it works. We'll enter 5, 6, 7, 8, 9. Prints them in reverse order. Lovely. Right. So this code is very solid. It works. It's very obvious. I guess some good things there, but it's totally inflexible. If we want to change that to 50 numbers or 500 numbers, it's going to be horrendous. If we just want to so it's 5 statements to do 5 things. And if you know this is never going to change, I guess it's okay, but it doesn't give us any power. It doesn't get us anywhere. It's much better if we give an array all sorts of possibilities open if we change this to an array. So that's 5 variables. So I can get the same capabilities by saying x5. Now I could just then. Oh, this is a bit stupid, but bear with me. I have the it's not actually. I guess it's an interesting transformation. I could go to moving an array and explicitly specify this, and I'm not really getting anything much. So that's the same program if I've typed correctly. Let's find out if I have. Have I typed correctly? Not quite. I went wrong there. Slack. Alright, that's the same program using an array. Really, it has nothing in the way of advantages. It's nice to see, I guess. So I can opt into 7, 8, 9, 10, 11. Does the same thing. Alright, same program, no smarter. Let's get smarter. Let's use a loop to print out. So there's a loop that executes once for each array element. Executes for index 0, 1, 2, 3, 4. Executes 5 times. I has the value in turn for each element of this 5-element array, and will read a value into it. And we can do this. We'll copy it down here. I encourage you to actually use a different variable. You can reuse loop variables if you're sure. This one prints out them in the same order they came in. That's not what we want, but I'd encourage you to compile things, get them working, and this would be a classic thing. I know this doesn't work, but I can check. I've coded this bit up. It's going to my job is to reverse the numbers, but I'll get a program that reads the numbers and prints them in the same order, and then work on reversing it. And it's easier to fix my mistakes. Oh, and it's Thursday's lecture. We'll get to hopefully to what that ampersand is, but for now we just know we put an ampersand there to allow scanf to change the variable. Alright, so I'll enter 1, 2, 3, 4, 5, 6, 7, 8. Alright, that was an accident, but I forgot a crucial thing here. Every loop needs something that's going to change the condition. So a while loop, unless we want a while loop that executes forever, something inside the while loop has got to affect the condition, so it eventually becomes false. So I forgot to add I++ there.
One thing that you might want to look at when you're seeing this is you might think to yourself, this is a simple loop, and there are already people in the chat who pointed out, we need an I++. But if it was a more complicated loop and you couldn't quite figure out what was going on, you'll see that when Andrew pressed Control-C, which stopped the program, you also got to see all the values that were there. And you might ask yourself, well, if I'd been through this loop 10 times, I'd expect I to be 10, but it's actually 0. And you could maybe use that to deduce something about what was wrong with the state of the program. So you can make a sort of guess about, well, I think that I should be 10, but it's actually only 3. So sometimes that can be really, really useful in terms of telling where you are or what's going on.
So, and that was good. I got really slack there. I jumped through that because I knew, but I should have explained what was happening and pointed you, say, look, you can see here I equals 0. In your tutorials, don't hesitate to stick up your hand or your virtual hand and ask your tutor to explain things, stop them. So yeah, when you've been coding for a while, you look at that and think, oh, there's no increment. But when you're just learning to code, you can't look at it and see it's wrong. All right, so now hopefully I've got code that will read. If I wait a minute, if I saved, I haven't saved. If I save, recompile, and run. Ooh. Ooh, what went wrong there? That's a bit of a worry. All right. Again, I got sloppy in my coding. That was, again, just accidentally. I'm thinking about other things, and I wasn't watching quite what I'm coding in. If you're more likely to make that mistake just because you're not used to coding. I have much less excuse, and I'm still making the mistake. So what's gone wrong? All right, in the horrendous colors here on the screen, we really should get better colors for these. In red's meant to mean this is very bad. Index 5 out of bounds for array int 5. So that means you've used an index that doesn't exist. Oh, then that's the next line. The valid indexes are 0 to 4, and you've used 5. Execution stopped here. So that's where it happened. At this line here, an index of 5 was being used. I is there, so I must be 5. And up down here, and DC's saying, yeah, when I stopped, I was 5. So, by the way, if you use other C compilers, you won't get this information. DCC bundles all sorts of hidden stuff into your program when it compiles it, which jumps out when an error occurs like this and tries to give you information like this. We'll show you in later courses the tools that do this so you can use them separately, but that's later. So now we've got DCC that does as much as it can for you. All right. But DCC can't tell you, Andrew, on line 14 you used I, you should have used J. You've got confused there, and I have. So I used J, and I used J. All right. Well, hopefully that's to fix the last of my stupid bugs. Another 5. Now, one thing you'll notice is I'm putting in all sorts of. If you ask to read in a %d, ask scanf to read an integer, it actually ignores spaces. So I can type all the spaces I like, or just one space, like that. And my printf is missing a new line, but it's writing out 6, 7, 8. Well, let's put the new line in. Last mistake. It's amazing how many mistakes you can make in a simple program and how much effort it is to get it to work. You're thinking, oh, but when I'm a good coder, I'll just type in the code and it'll work first time. No. You'll get better at not doing stupid things, but you'll still have to. Yeah, you'll end up doing more complex things and having to deal with the same problems of things not working. 5, 6, 7, 8. Oh, come on. Oh, apparently I missed when I tried to save. What was going on? Why isn't that saving? Oh, it did that time. Alright. Alright. That's not bad. So this is what I'm talking about. I've got half a program in. I know it doesn't do the job I'm trying to do, reverse the numbers. I'm just printing them out in the same order. But it's actually easier to debug all the stupid bugs I've got on the simplest possible code. Now I make my code more complicated to finish the problem, but I've sorted out a lot of the easy stuff. I've got reason to believe what's on the screen works in terms of printing things in the same order they're entered. Alright, so let's try this out. So if I start at J as 4, and my loop condition is, and I've got to think about this, I want this loop to execute for 4, 3, 2, 1, 0. So I want this loop to execute for J being 0. So that's the loop condition I want, and that's a hard thing to get right. So let's see if I've got a loop that does that. I'll enter 4, 5, 6, 7, 8 as my 5 numbers, and let's see, print out 8, 7, 6, 5, 4. Oh, Why isn't that save? Sorry, my save shortcut, or I'm typing the wrong shortcut. Let's just clear the screen, compile my program, check it's saved, take a breath, run my program. Oh, things went wrong again. Alright. Index 5 out of bounds again. Where was it out of bounds? Which line of my program? It's saying there, which is here. So things went wrong. Alright. Key life tip. Whenever you use an array index, try to do a little mathematical proof in your head that the array index is valid. So X, you can look back and say, oh, we're back. All right, apologies for that. Valid array index is 0 to 4. So can you do a little mathematical proof that J must be in the range 0 to 4? You won't be able to here because we're DCC stopping and it's saying, look, J is 5, you're trying to access index 5, it doesn't exist, your program's broken, Andrew, I'm stopping now so you can figure it out. DCC is doing an enormous favor, by the way. A lot of C implementations, you might get a C implementation for your laptop or whatever, it won't stop here, it'll keep going and do bizarre things, and it's much harder to work out what's wrong with your program. DCC is doing an enormous favor by stopping it as soon as it goes wrong, as near to the problem as it can. So I think J is 4. The loop says don't go below 0. That's great. J can't be below 0. Then I look down here. Ah, J++. I forgot that bit. So this is going to be, you're going to do a lot of this, lab exercises, assignments, figuring out exactly this sort of stuff. But you're smart. You've got into UNSW. Trust me, you're smart. You may well be smarter than me. You haven't done nearly as much coding as me, so I can do it easier. But you can learn this stuff. You can figure out how to think about it. Think about how you can make little bits of reasoning steps, little bit of logic steps. Think about little bits of a little logic puzzle. What can I prove in my head about J? What can I decide about J? I don't know, some of you might have done Sudokus, where you do little bits of reasoning, saying if this is true, then this is this number or that number, then this must be that number. The same little logical steps are your first steps to really being a coder. Alright, a working program. Now, I want to show you two things about this program, and then we'll have a break. The break will be a bit late, sorry, but we will have a break. But I want to finish two things about this program. There's one easy thing I want to show you. There's one rule I've said. Well, actually, there's two things I'd say here. One is this program's too crowded. If I can't shift these off to separate functions, probably this should be a separate function. So I probably should shift this off to a separate function. But if you don't want to do that, at least sort of put a blank line in there to make it a bit more obvious. This is one sort of unit, one separate task happening. So we've got one task happening here, which is printing the numbers, one task here that's separating the numbers. So don't hesitate to put some blank lines to make your code a bit more visually obvious, a bit of graphical clue to how it breaks down. Yeah, but here's the big thing. I said don't do this. Yeah, in general, don't do this. That's a key number, and it really should be hash defined. It's hard to. What do we call it? I'll call it size. You can call it many things. In this one, it's a bit hard to. Oh, no, I'll say n numbers. There we go. Hash defined. in numbers as 5. All right. Make that in numbers. And go through your program, and I'd call it parameterizing your program. Use this constant instead of 5. Now what about that 4? Should I hash define it? No, a better thing that you could hash define it, but a smarter thing to do is this. What is that? It's in numbers minus 1. All right. Look at that. All right, I'm so smart. Let's see if this actually works. Hint, never say I'm so smart. It never goes well. Oh, look what happened there. I forgot that there's one place hash defines don't work. It's a good thing, it's a great thing, it's a good thing definitely. Inside double quotes, where we're saying put out these characters, hash defines don't apply there. It's a good thing. There's a trick though we can use. We can say, oh look, fill in an integer here. What integer? Oh, whatever the value of this in numbers is. So it looks weird, but it's a simple trick really. It's not that clever at all. Have I managed to save? Yes, I have managed to save. I compiled, and I should be able to write out the 5 numbers in reverse order. All right. Now, there's one more thing I wanted to show you. Scanf is a function. Scanf returns a value. Printf actually returns a value. Printf, I think, returns the number of characters it wrote, which is almost never of interest. So that shows us we can call printf and just ignore what it returns. And everyone ignores what printf returns. It's a bit sad for printf, but it will faithfully return, you know, how many characters it wrote, and everyone will ignore that. Scanf returns something important. How many things it managed to read. What could go wrong for scanf? Let me show you. Let me see if I enter 5 numbers and I say enter 8, 7, 6, and I type in hello scanf. Oh, things went badly wrong here. Down here, DCC saying, look, you went to print out xj and you never initialized it. You never gave it a value. What was j though? Xj, j is 4. You never gave a value to element 4 of the array. So scanf couldn't put something in element 4 because I didn't enter a number. So scanf managed to fill in this array with array element 0 with 8, array element 1 with 6, array element index 2 with 8, 7, 6, and then it couldn't put anything into the array. If you haven't put anything in the array element, printing it out is an error. And DCC actually picks this up and says, stop, look, this array, you tried to print out array element 4 and you never put anything in it. Goes to some lengths to do this. It's this, and we worry about it a lot because this is one of the biggest sources of security holes. One of the biggest problems with cybersecurity is this sort of error in programs. You're saying, well, Andrew, I could just initialize the whole array to start with. And that half solves the problem. So let's initialize the whole array to start with. So the array's got something. Then we'll fill in the arrays with zeros, and then we'll use scanf to put a second lot of values on top instead of those zeros. We'll see what happens when that happens. That should get rid of the error, but then we should see the zeros we put in the array. So I'm going to enter in, I entered it here, 876, and again I'll say hello scanf. So scanf will see, it's trying to read a number and it sees hello. Well, you can't turn that into an int, so and there we go. There we're seeing the zeros in the array. What can I do about that? What can I do? So I can get the number of things scanf read like that. And then I can do something if n things read. Alright. So if scanf doesn't manage to read one thing, we're only asking it to read one thing. So if it doesn't read one thing, what do I want to do? I can stop looping. Yeah, how am I going to stop looping? I'm going to set up a sentinel variable, add an extra variable. Actually, no, stop looping. I'll go with keep looping. You've always got a choice here. Is the variable to say keep looping or stop looping? Probably it's easier if I say keep looping. So I'll make the variable 0 if we shouldn't keep looping. And I can use an AND. So in my master plan here, I set up a variable just to control the loop. I'll set it initially to 1, so the loop executes as normal unless something changes. But if scanf doesn't manage to read one thing, I'll set that variable to 0, and then the loop will stop next time. So that loop will stop as soon as scanf fails. I need one more thing here. That still actually gives me the same program. It's a better program in some sense.
And it might also be worth noting we're just on 10 minutes past the hour, so maybe either we do the last thing now or we leave it as a cliffhanger, which I'm told is also a good part of drama too.
Oh yeah, that's it. That's a good point actually. Yeah, let's take the break. So this is not a different program, but we'll take a 5-minute break with a cliffhanger, which you can try and resolve. So if I go, tell me how I can get this program, if I only enter 8 and 7 and then go hello, it prints out, doesn't print the zeros. So we don't want it to print those zeros. Can you change the program? So if scanf only reads 2 numbers, it only prints out 2 numbers. So if scanf reads 4 numbers successfully, it prints out 4 numbers, and so on. So can you make the last change to this program? Alright, so we're taking a 5-minute break and we'll be back with you shortly.
also looks like there's a question in chat, which Alvin thinks it might be a good idea to ask.
Break and continue.
Yeah,
I can see it. Yeah.
Cool.
All right, everyone. Yes, I'm just chatting to Tom about what's in the chat. Alvin saying, "Oh, you should say something about break and continue." All right. So there are two special statements which we're not going to talk about today or Thursday for controlling loops in C, called break and continue. Well, not just C. Lots of languages have copied their C use, and C stole them from another language. This example could use break, and someone's saying, "Oh, I think it might be more readable with break." Yeah, I can see the argument for that. But this technique I'm showing you here of this sentinel variable, it's incredibly powerful. So there are multiple ways to solve this, sure, but what I'm showing is an incredibly powerful way to code this use of a variable like this to control the loop. And this is a simple exposition, but because it's a simple exposition, it could be used with break. Why aren't I showing you break now? And break is, it's not so bad, but it's better if your coder really learn how the basics works before you start using break. It can often confuse yourself adding ifs and breaks to loops, and continues even worse. So students often make their code better with break. Like more than half the time, if students start using continue in their first 5 or 6 weeks of coding, they make their code worse. They create bugs for themselves and make it less readable. So I think the style guide says generally don't use these unless you're really sure it makes your program better. We don't want to stop you. One thing that worries me is, you've learned some coding elsewhere, you've written Python with breaks and continue, you've read a great tutorial. I don't want to penalize you for stuff you've learned. So if you use things that we haven't talked about, I don't want to penalize you, but we strongly encourage you to just use the stuff we talk about, and stay with the group so everyone's sort of on the same page, we're learning together, the tutors are answering the right sort of questions and so on. So you won't get penalized for using other stuff. You won't get penalized just for using other stuff. If you use a lot of continues and your program's unreadable, your tutor will give you a lower style mark. But in general, it's best just to keep with what we've talked about in lectures, and nothing's going to get super easy. Yeah, reading about other C features won't make the assignment super easy. No, definitely not. We've designed the assignment to be done with the features we've seen so far, and there's no mysterious things that's twice as powerful that we haven't told you about. Alright, so my loop is printing out these zeros here. Oh, Tom was telling me, Andrew, this is a big spoiler for one of the lab exercises. Yeah, I'm sorry. I'm really sorry about this. This apparently is too much help for one of the lab exercises. I feel very guilty about that. I didn't read carefully what one of the lab exercises. I've done that before too. I really should be more careful. But so this was meant to tie into a lab exercise, just goes a little too far. So my problem is it's writing out these zeros. How do I stop it doing that? If it read 2 numbers in before saying hello, well, where do we start? Our loop starts here. Let me show you my idea. I want to write out the last thing read in. Well, the last thing was read into array element I, but note I has been incremented there. So I reckon I want to start the loop at I minus 1. Alright, and so we'll start in at 8, 7, 6 and say hello. Oh, so close. 0, 6, 7, 8. That's actually got me surprised. Why isn't that working? Oh, because the scanf, the last I, the scanf failed, didn't it? So maybe it's I minus 2. Well, that worked, but what happens if I enter all the numbers? If I enter 6, 7, 8, 9, 10. Oh, then he enters the last 4. Oh, that's broken as well. That's... Oh. What do I put there? Actually, might leave that as an exercise then, fixing that code. All right. As Tom's telling me it's related to a lab exercise, so I've got to do something different there. There seems like there's 2 possibilities. Or So we'll leave that as an exercise and move on to a completely different example. Let's scroll down. Alright. On to our next game. Imagine... Oh, actually, let's talk about two-dimensional... sorry. First, before we talk about the game, we have to talk about multi-dimensional arrays. We have an array of some type of variable. You think, well, I said we've seen int, we've seen double. So you can have an array of int, array of double. Every array element must be the same type. Arrays have fixed size, they don't grow in C. So if it starts out with 8 elements, it's always got 8 elements. And every element is the same type. So if element 0 is an int, element 2, 3, 4, 5, 6, 7 are also ints. But arrays can contain any type of variable. And an array is a type of variable, so we can have an array of arrays. These generally get called multi-dimensional arrays, but they're really an array of arrays. You can think of them as, if it's just an array of arrays, you can think of it as a grid, but it could be 3, 4, 5 dimensional. I'm not sure we'll get into 3 or 4 or 5 dimensional arrays, but assignment 1 involves a 2-dimensional array. How's a 2-dimensional array going to work? You can think of it as having to supply an index to get you to an array element, which is itself an array, which you then supply another index. So you might have an array where you're supplying an index between 0 and 4 and an index between 0 and 1. You have to supply 2 indices, 2 indexes to get an array element. This shouldn't be too scary for you, because it's like using a pair of integer coordinates, and you've done lots of coordinates in high school maths. Note again, all inner arrays have to be the same type and the same size. So you don't just have an array of int, you have an array of int of size 3. Everything is rectangular, or if you like. Let's look at the code for this. The code might be better. So this declares an array of arrays of size 4. So this gives me the possibility of holding 4 times 4, 16 elements. I can initialize it and say 0. The first element is 0. Then, because I haven't specified any more initializers, all the other array elements will be 0. Now when I want to access an individual array element, I have to specify 2 indices, 1 and 3. There, and I can assign a value, 2 and 0, and do a comparison. Yeah, that code. Ignore the code there. Let's look at actually how we might use this in a game. So let's have a game where we've got a tourist walking around a square grid, and we'll have the tourist walk up, down, left or right. We'll print out the world, including the location of the tourist. We'll track which squares the tourist has been, and we'll stop the game if the tourist revisits somewhere where we've been already. So we'd like the tourist is on this square grid, and the tourist should be able to we should be able to say go up, go right, go down, go left. But if we ever get to a square we've been to before, then the game should stop. So here, to get us started is a function. You're going to be doing a lot of coding like this. You're going to be told, look, we want you to do this task, but here's a function that always does X, which you can use. And it's not just first coding courses, second coding courses. So much of the work you'll do when you'll have existing code, that does X, and you'll want to utilize it because you will need to do Y. You'll have to compute some sort of statistics for an experiment, and you'll call functions in the statistics package that calculate a t-value or something like this, or plot out your data. So we're giving you a function that prints out an array, a two-dimensional array, and prints out, it's told, that's where it's not very good names, it really should be tourist row and tourist column. It prints out a T where the tourist is, and otherwise it prints out the value of the array. Yeah, let's try this out. Let's, rather than talk about this abstractly, let's try it out. I hopefully have code ready to go. Here's code. Oh, what are we missing here? Oh, we really need hash defines here. So the size of the world, hash define. Where do we go? I think we'll go 10 by 10. Map raws. Hash define. Map columns. 10. There. So down here is that helper function. Oh, look at that. I've said the crucial thing with a function, the most important comment in a program is the first one right at the top, introducing you to the program, who wrote it, what it does, what its licensing is there a web page associated, is there a repository associated with it, all sorts of important information. Next, for each function, the most important comment is before the function, telling you how you call this function, what it gives back, what you should be aware of, what it does. So this function gives back nothing. Takes an array and two values, actually a coordinate, if you like, in the array, and gives back nothing. What's the value of a function that gives you back nothing? It prints out stuff. So it prints out stuff. So there's my print map function. Otherwise, this function, yeah, it looks like we could have coded this up ourselves. Except, it's a bit clever. We saw a single while loop used to do an operation for every element of a one-dimensional array. We've got a nested while loop to do an operation. So we have a while loop that does one execution for the first index. So this executes once for every valid value for the first index, and within that while loop we have a while loop that executes once for every valid value of the second index. It's a bit scary. I think we should try it out. Let's try it out. Called print map, and this is not bad advice for something like the assignment. You've been given a function. Let's see if we can call it print map, and we'll put the tourist at 3435. All right. Okay, I guess we should have highlighted this. An array of ints. It'll be map rows times map columns of ints. I've said initialize the first element, index 0, 0 to 0. I haven't said what to initialize in the other element to, so they also get initialized to 0. Will that compile? Can we start our work on our tourist program? Oh. There we go. Oh, all right. Fingers crossed. We're started on writing the game. Ah, look at that. Isn't that beautiful? So it's written out our little grid. Our tourist has started off at 3.5 randomly. All right. So we want to move around this grid. Now stopping is going to be a complicated thing, so I'm going to use the same technique as I used before. Actually, keep looping. So this is this is a scary loop. A lot of the simpler loops, which execute 0 to 4, they're easy to understand. We need a more powerful loop. What's our stopping condition? You want to keep looping until the tourist walks onto a square they've been before. What else we need here? Something like this. I've got a message here off the screen, but let me... something like this. Oh. I don't know if you're gonna... No. Sorry, I'm VLab is not playing nice with me in cutting and pasting. So we get them to get the person to type in 2, 4, 6, or 8 on the numpad to move in that direction. So we put a message like that there, and then read in the direction. Yeah, I can see things wrong here, but let's keep going. Direction equals 2. Yeah, we'll do something, I'm not sure what. And we'll print the map. So oh, yeah, I'm missing something, aren't I? More variables. I need to track where the tourist is. Tourist row, tourist column. This is always the thing. You've got to think about, in these cases, what do I need to store? What variables do I need to represent? So we'll start the tourist off at 3 and 5. All right, here's my grand plan. So if I type in a direction of 2, that's down. So that's minus. All right. Yeah, stay with me here. So I've got 2 variables that track where the tourists are. Tourist row and tourist column. I'll ask the user to type in 2, 4, 6, or 8 on the numpad to say which way they want to go. I'll read in what they type. If they type in 2, I'll subtract 1 from the row. I'll have to do similar ifs for 4, 6, and 8, but let's see if that compiles and that works. Now you're saying your loop never stops. Yeah, one thing at a time. One thing at a time. And I haven't saved now. Oh, expected semicolon. So close. This time for sure. Alright, I'm typing in 2 and we should go down. Oh, we're going up. Oh no. But you can see my tourist is heading up in the world there.
So it might just be worth drilling down into this a little bit, because I think there's some people who are still just trying to get their heads around it, which is fine. What we're seeing here is we've got a two-dimensional array, so an array of arrays. Everything in it is set to 0, except there is one place in it where we're going to say that there is a tourist there, and that's represented by the T. And we've got some code in print map that you don't really need to worry about, but it just prints out the current state of that array, except wherever the tourist is, it prints out a T instead of that person, or instead of the number that's there. And so what we've got here is we've got code that allows us to move the tourist around. Every time we type in a 2, that's kind of effective to pressing the up key, and it moves the tourist up 1. So just so everyone sort of can see what this is going on, at the moment it's just an array, a two-dimensional array of all zeros, and then we're printing out a T in a place. And maybe now we can start modifying the array. So maybe now we can start moving the tourist in different directions, just so that people are hopefully on top of what's going on.
Yeah, so there's our two-dimensional array. Our array we have to specify 2 indexes for, and 10 possibilities for the first one, 10 possibilities for the second one. So 100 things we print out. We're printing them out as a square there. We've already been given code to do that. And for the assignment, you're going to work with a two-dimensional array, and you're already given code to do, I think, to print it out. Let me scroll down. And this clever function prints out the array with one exception. At a special coordinate where the tourist is, if you supply the coordinates, the row and column of the tourist, instead of printing out the array, it'll print out a little t. So that then lets me use 2 variables to track where the tourist is. When I say to print map, I say print out whatever's in the array and print out the tourist, but put a t where the tourist is. So when we start the program at index 3, so it's 0, 1, 2, 3, 5, which is 0, 1, 2, 3, 4, 5, put a t. And because I'm recording in 2 variables where the tourist is, I can change it. So if the user puts in a 2, I subtracted 1 from it. Let me now try more code along that line. So this, what I should have done is a 2 means go down, which is that direction. So what's the opposite of a 2 on the numpad? On a numpad, an 8's the other direction, so we should twist row. Alright. Yeah, it's a weird loop, isn't it? The loop actually never stops. We're halfway through writing the program. We've got a variable to control it. We set it to 1 and we never change it. So the loop goes forever. That's still to be done. That's pretty common in coding. We haven't finished that bit of the program. But have we got something that will shuffle the tourist row up and column up and down and change where the T is printed? So let's try that out. Let me interrupt the program, Control C. Oh, look, you can see it printing out the 2D array. It stops after a while because it's showing you, oh look, the first 10 elements, 0. Next 10 element, 0. Next 10 element, 0. Gives up after a while. Here's tourist column. Here's tourist row. And where was it when we stopped? It was in the scanf there. So it was trying to read a number here. Compile. Execute. Alright. So it's printing out the array. The array is all zeros. Why is it printing out as a square? There must be a clever use of a new line further down. Yeah, here. That's why it prints out as a square. This week's lab, oh no, it was last week's lab was big on that. putting out your lovely X, and the shoot question where you do a chess. I love the chessboard. Your first integration, sort of, you can actually get deep into the world of art with much more complex things and patterns, but chessboard's a little start. So that's why it prints out as a square. Can we successfully change the 2? So the 2 should make our tourist go down. Oh, look at that. Our tourist is going down through the world. And if I've got it right, an 8 will make the tourist go up. No. So sad. That should be minus. Okay. Sorry about that. But think about now, while I do code this and run it again, or while I compile and run again. Eight will take me back. Ah, look at that. Now tourists can only go 2 directions, but they're it works. All right. Now, there's a couple of issues still to tackle, and I don't want to worry you, but we might not get through them all today. But let's think about a few more of them. We want to know where the tourist has been. So, how do we do that? How about we store in the map? So we record tourist has been here. Yeah, should I be using a 1 there or a hash define? Probably a hash define, but we'll just you put a 1 in there for now. Can we now see where the tourist has been? Right. Why isn't my code working? I mustn't have recompiled, didn't I? Try again. Ah, there we go. So you can see now for every square the tourist has been, it's been changed to 1. Alright. How can we make that into, we want to stop if the tourist ever goes back over a square. You can think about that while I code up the other directions. I need 2 more directions handled, and I think I know how to do those. They're sort of logical. So the other possibilities they enter are 4 and 6. So I think 6 should make the column plus plus. And I think 4 should make the column, should subtract 1 from the column. So keep thinking about how we stop the loop while I compile this and see if I got the tourist moving in 4 dimensions. Alright, so let's try for our first go left with a 4. Oh, there we go. Let's try going down with a 2. Let's try going right with a 6. And another 6. Another 6. Oh, this is fun. And then down with a 2. And right with a 4. Oh, I might just stop coding and play the game for the rest of the day. Alright, so we want, if we do another 8 there and go onto that square we've already visited, we want the game to stop. So how do we do that? How would we get that to happen? So the move has taken us onto a square we've seen before. Let's stop. Yeah, the if statement's hard. We know how to stop. We just set the looping variable to 0. Probably a good idea to print something out. Just a message. Our stop. Well, if we check the row we've been before, sorry, we check the array element. If we've been there before, what will it contain? It will contain 1. So that gives us a way of stopping the loop, deciding we're done. The tourist is on row and column, visited square, so we can print out a message saying visited square before stopping. We'll set keep looping to 0, and that should take us out of the game. I'm hoping, let me scroll that down a bit to make sure we've got all the key code on the screen. Yeah, it just gets all the key code on the screen. Sorry, we'll shrink that 1 just to keep everything together. Oh, that's not too bad. Alright, let me make sure I've saved my file. Stop my loop. Have I got a loop that... So we'll go right with a 4, and if we go left with a... Oh, actually we'll go down. So we'll go down with a 2. Ooh. I'm not sure what happened there. Yeah. Interesting. Seems like there might be something not robust in our program if I type in something invalid. We'll have to check that. So let's type a 2, then a 4, then an 8, and then a 6, and a 6 should stop the program. So we have a stopping condition. So this is quite nice. You might be able to contrive that loop so you don't have a controlling variable, but it's just so easy to understand the controlling variable. Set the controlling variable to 1 while the controlling variable is 1. Keep looping. When we want to stop looping, set it to 0. Very powerful. Alright, so I'm really worried that this program's not robust, that things can go wrong with it, but I think it does a lot of things right. It just doesn't check for various things, so it can break in various ways, but I think it does the core functionality, the core thing we're trying to do correctly. It's a little weird, we always start the tourist at 3.5, but I guess we could start them in the center, perhaps, or something like this. Is there anything else I should say about this code, or is there any questions in the chat, Tom, before we move to making the code a bit more solid?
I think that people seem to be all right on being comfortable. I think you've also given a reasonable demonstration of what's going on. There were some questions earlier about the scanf stuff, which might be good to go over if you're planning on doing that.
Oh, that's good. Yeah, no, I'll do that now, yeah.
Okay. But I think apart from that, I think you've demonstrated this reasonably.
Thank you. All right. Let's see what happens if I...
Oh, and there's also there was a question before about what happens if you go outside the box? Like if you press 6 constantly.
Yeah, so that's my worry too. I'm on board with that being something that has me worried. All right, what happens if I type in something that's not a number? Oh my God, things went badly wrong there. All right. how do we fix that? All right, so scanf gives us back how many things it read. And that should be 1. We've asked scanf read 1 in. It is possible to ask scanf to read multiple things. It's generally not a great idea. Normally we're reading 1 thing. But it could return 0 to say it couldn't read anything. It could actually return other values, but something's gone wrong. There's something bad happening. If it returns not 1. So what can we do?
I think it might also just be useful because I remember there was somebody earlier who did want to clarify that a bit. So just to be super clear about it, scanf, like many functions, returns a number. That number is effectively the number of things that you gave it. In other words, if you said scanf%d, you could give it 1 thing, so you could give it 1 number, in which case it would return 1, or you could give it nothing. For instance, if you typed in some letters, or possibly even if you press Control-D, which will give you a slightly different value, but still, you would get something other than 1. And so what we're doing here is we're saying, have I received 1 value exactly? If it wasn't 1, that would mean that maybe they've pressed Control-D, or maybe they've typed in a letter. And this is now allowing us to do something we haven't been able to do before, which is to control whether or not our program has received valid input and make decisions based on that. So make a decision based on whether we received a number or whether we received something else. Hopefully that's going to clarify any questions that we chat earlier.
All right, on the screen is my, it's not necessarily the best approach. I think there could be cleverer things you could do here, but this is sort of a simplest approach. So I've said, I've put how many things scanf managed to read in a variable. So if it managed to read a number, that'll be 1, and we'll execute all of this code here. Notice how I've indented it across 1 position because I've got a giant else there. It's not necessarily good. We like to write our code simpler than that, but at least it's nice to see you can use an if statement like that. I say keep looping equals 0, otherwise I do this stuff. And maybe I should print a message there saying scanf failed. There we go. Scanf failed. Right. If I've got that right. DCC says valid C. Is it C that does what I want? Alright. Type in hello. Scanf's trying to read a number, can't. So it returns 0. Rather than changing direction to the int it read, I said hello, it can't turn that into an int. So it says, no, I couldn't read anything. And this code was executed. I said keep looping to 0, and the loop stopped. Alright, that could be more user-friendly. Your user may not even know what scanf is, but that's good for now. What else would worry us? Oh, walking off the board. Alright. What happens if we walk off the board? I type in 2, 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 type in 2. Oh! What happened? Where did I die? Here. It's saying you stopped there. Line 35. Here. Yeah, DCC's careful about telling what went wrong. Yeah, you can see there's so many array elements, I can't really see what's in the array from what DCC prints. Yep. It's saying you got to 5, 10. Oh. Yeah. DCC's error messages are not very good with well, I know, the error message is good. Yeah, index 10 out of bounds. So it's saying index 10, two-dimensional arrays are a bit trickier for DCC to give you good help with. And it's really the underlying tools. It's saying one of these indexes is wrong. I can look them up. Tourist column is 5. Yeah, that's a valid index. Tourist row is 10. Valid indexes there are 0 to 9. We can refresh our memory if we want. Scroll back up. Yeah. Oh, hash define makes it a little harder. Map rows is the size there. That's 10. So valid array indexes are that. So we've used an invalid array index. That's really my clue, isn't it? What can we do here? There are a few possibilities. Basically, we want an if statement. We've already seen this, yeah. What do we do? Things have gone wrong. And there's no right answer here. It's a design question. What do I want to do in this circumstance? I could just leave the tourist stuck at the edge of the board. I could stop the game. How would I leave the tourist stuck at the edge of the board? So the tourist row has got too big. We could force it. We could just say if you try to go off the edge of the board, you stay on the edge of the board. So if you try to go to 10, we'll limit you to 9. Yeah. We'll keep you within the array. How about that? Now it's not the only one. There are 4 different sides. So I think we need 4 if statements, but I'm just going to do one here to show you. We're running out of time together today. So I'm about to code there to stop. But this bears back to what I talked to you. Every time you use square brackets, you should be asking yourself, how do I know that array index is within bounds? And if you don't, often the answer is add an if statement or change a while loop, add code beforehand. If you're using an array index and you can't be sure it's within the array, you probably need more code to check that. So every time you use an array index, you should be asking, how do I know that's in the range 0 to n minus 1? Right. Have I stopped the problem of running us off the bottom of the board with that? I've said if you get to that, if the row number gets too big, limit it to the clamp it. There's a word, clamp it to the maximum possible value. And I've completely forgotten what the hash define was called. Alright, hopefully this will compile. Yep. And will it stop me going off the end of the board? 2, 2, 2, 2. Oh, haha! Stops the game. Hidden impact because we stayed in the same square. What if I don't want that? What if I don't want that? Oh, interesting. If I don't want it to stop the game in that circumstance, that would be my solution. So if we've hit the edge of the board, do that. Else, if we've been here before, stop the game. But not do both. If statements aren't quite as simple as they seem, are they? Changing that to be else if changes the program completely. Let's see if that works. 2, 2, 2, 2, 2. And hopefully we just stay stuck there now. And now we can go 4, 4, 4, 4. And we'll have a different error with a 4. So we'll have to add 3 more if statements there to stop it going off the other edges of the board. You're saying, I could be super clever and do one if statement. Yeah, maybe. Though it's easy enough to write 3 really simple, obvious if statements, whereas to write one, maybe it's less obvious and hard to get right. Writing less code is not necessarily a virtue if the code is more complex and harder to understand and harder to make sure it's correct. All right, we have 1 more minute together, so I'm going to switch over to Tom to see if he's got any thoughts or questions.
So I'm not sure there's anything else right now unless Alvin wants to highlight something particular there is to go over.
A huge shout out to Alvin, by the way, who's been frantically answering questions in the chat and answering them well. Thank you, Alvin.
Yes, absolutely. I think it's worth noting just generally that this is very similar in terms of like the structure, well, in some senses to the structure of what your assignment will involve. So in your assignment, there's a separate sort of function which does some printing stuff. There's also going to be some scanning inside of a while loop and lots of if statements inside of that while loop as a result. So this code is quite useful. If you're not entirely sure on it, don't worry, because you'll see more code like this and you'll get a chance to look over the assignments code as well. But this is the very same structure that we'll be using in assignment 1 in Minesweeper. Alvin seems to be good. I can't think of anything else to say, I don't think.
All right, so yeah, I would say, let me repeat again. There are a lot of students out there thinking, look, 95% of the class has understood this, and I haven't, and I'm not going to survive in this class. No. 95% of the class hasn't understood all of the aspects of this code we've done. 5% of people have done a lot of coding before, or just find this stuff a bit easier than most of us, and they've understood everything we've covered today. Most of the class has only understood parts of this example. We're covering big concepts, big, huge, important concepts, and we're going to revisit them again and again in lectures, in lab exercises. Tom's going to do a live stream to help you get started. I would suggest, by the way, try and read through as much of the assignment spec, understand all the easy stuff before you check into Tom's live stream about the assignment this evening.
Can I make a quick comment on that? When we say read through the whole thing, what we mean by that, read through everything up until the end of stage 1. If you found that okay, you might want to have a look at sort of stage 2, stage 3, stage 4, those sorts of stages. But really the important thing, especially for this week, is just making sure that you're clear on the concept and clear on stage 1. Just because I think some people, like, if you're the sort of person who's not entirely confident with this sort of stuff, reading through stage 2, stage 3, stage 4 is useful to give you some context, but there's also a lot of content there. So we'll talk through all of that in the assignment live stream this afternoon, but I agree with Andrew, definitely have a read through everything up until the end of stage 1 at least, and if you're interested, you can have a quick skim through the rest of the assignment as well.
Yeah, but so look at stage 2 and 3 by all means, but if it just makes 0 sense, don't panic, just go back and see what you can understand in stage 1. Yeah,
the stages are designed to build up on each other, so you will learn stuff in stage 1 that then you can apply to stage 2, and you'll learn stuff in stage 2 that you can apply to stage 3. Which isn't to say that you haven't learned all the content already. It's more just a question of you get lots of practice from the assignment, because the assignment is just more coding, if that makes sense.
Lots of good questions in the chat saying, what if? Well, you've got the code, by the way, for this. I've changed topics. About saying, what if in the tourist thing I did this? You've got the code, you can take the code and you can try doing what if things as well. And it's not a bad thing to try out ideas for the assignment in that sort of way. Live stream is 5 p.m. All right, thank you, Alvin, for all your help in the chat. Thank you, Tom, for all your help through the lecture and for doing the live stream at 5. I've got a few things on today, but I'll see if I can check in to the live stream and see how it goes. But otherwise, I'll talk to you all on Thursday 2 o'clock. See you then. All right, thank you, everyone, for tuning in.